Meet Donald. He's a plant manager at Cargill, so naturally he's concerned about safely maintaining and improving overall production at his plant. He knows that setting the right production rate and always working to improve is key to doing this, but that's hard to do when problems occur. Often, these problems seem beyond his control, and finding the root cause is hard. So, how can he work with others to solve these problems? This is Dent Remediation. Simply stated, improving production isn't just about pushing our plants and our people as hard as possible. Donald knows that isn't safe or sustainable. What he really wants is his plant production to be consistent and predictable. In order to improve our production, we first must have a clear understanding of our current and past production performance, or baseline. We do this with data. It's important that the data we have is accurate, precise, and complete. This will be key to measuring problems in our production process and then improving on it. We can use the baseline data to find our best run. Our best run is defined as a 28-day period where we had the highest total production. Once we define the best run time period, we use data from those 28 days to define 3 key figures for our plants. Capability is the maximum production that the plant should target each day. It is what we've been able to do at least 25% of the time during our best run. Maximum average is the most the commercial team can request each day. And stability factor is how we measure our consistency. Our final goal is to safely produce as much as possible with as little variation as possible. The actual goals will be specific to each plant. The result of achieving these goals will be safer and more reliable production. So what causes us to have unreliable production? A closer look at the data gives us a good idea. We can see over time where we have production losses. It could be a slowdown or a full stop in production. We call these problems dents. Dents are unwanted events, bad days, and opportunities for improvements. There can be safety, quality, yield, cost, and throughput dents. We will focus our discussion on throughput dents. A number of things could cause throughput loss. Equipment failure, poor quality of raw materials, or maybe a shortage of workers, rail cars, or trucks. These are all things that could cause dents. If we can remove these dents, we can improve our overall performance. But more importantly, if we can remove the source of these dents and improve our standards, we can prevent the dent from happening again. Let's take a look at how we do that. All of our throughput data and losses are recorded, tracked, and displayed for the team to see in our real-time tracker, RT Duet. This lets us know exactly when a throughput loss event occurred and how big it was. From here, we can assign a category to the throughput loss. By highlighting our dents like this, we can see their impact and prioritize our work. These are the problems we want to tackle and fix. Dents are recorded on our IDEX, Integrated Daily Execution, visual management boards. They're a great way to meet daily and talk about our performance. Seeing the dent up on the IDEX boards makes everyone aware of it and allows us to assign an owner to find the source of the dent. Today, Donald was assigned the task of finding out what caused 1 hour of downtime yesterday. At IDEX, Donald received the 5 why from Igor, the operator who identified the dent. Igor wrote that the loss occurred when the high-level switch in the finished meal conveyor discharge spout was triggered. This locked up the equipment and shut down the plant. Igor logged the dent in the dent tracker and checked the dent list to see if it was reoccurring. It wasn't. He decided to go to the equipment and take a look at what was happening. He noticed the level in the conveyor discharge spout was not high, so he safely shut down the equipment and inspected the high-level switch probe. It was dirty. After cleaning it, he concluded the production loss was due to a dirty transmitter. The next day at IDEX, he shared his findings and 5 why. In an effort to prevent it from happening again, the team discussed having operators inspect this probe once a month and cleaning it during the scheduled down day. Since the actions were logged, the team erased the dent from the board. Well, a few days went by and the probe triggered again, causing throughput losses. At the IDEX meeting, an action was placed on the board again and assigned to Donald. Donald figured something additional was wrong, since he knew Igor cleaned the probe. He went out to the plant with Igor and inspected. The level in the discharge spout wasn't high at that moment. He thought, well, maybe we're getting product surges that caused the high-level probe to trigger. While he was out there, he noticed a flap gate downstream of the conveyor and discharge spout. Could our product be backing up when that flapgate changes positions and directs flow to a different conveyor? Donald went back to his office and pulled plant information data from the past week. Was there anything in the process that had changed recently? He looked at equipment amps, temperatures, and pressures, trying to determine if surges of flow were moving through the system, but nothing seemed to stick out. This called for a deeper investigation. The next day in IDEX, Donald shared his progress. The team suggested they perform some trials. Donald and Igor safely conducted a few trials during the day. They noticed that when they ran the gate to the truck system, the process seemed to keep up. But when they ran the product to the rail system, it wasn't being taken away as fast. Why was this? It was Tuesday and time for their IWEX, Integrated Weekly Execution Meeting. In IWEX, the team reviewed the Dent list, followed up on the investigation from the past week of Dents, and discussed the investigation. They also followed up on solutions implemented to make sure they were holding themselves accountable to timelines, actions, and quality of cause analysis. Donald brought up that they still hadn't found the root cause of the dent he'd been working on. The team decided to use the A3 problem-solving process. Donald gathered a team of operators, maintenance, and engineers, and together brainstormed different possible causes for product not being taken away fast enough. Over the next week, they safely tested all of their theories. They found that when the flapgate was sending meal to the railcar system, the elevator leg couldn't move the product away fast enough. They'd been running stable in the past and had recently increased rate by 1%. Maybe this small increase was just enough to cause this leg to be the bottleneck. After discussing sizing and design with the manufacturing technology team and vendor, the team completed the MOC, or Management of Change process, and was able to apply a short-term solution to slightly increase the speed of the leg. Once completed, the finished meal was removed fast enough so that it didn't back up. They fixed it. A plan was made to permanently increase the size of the leg. This solution tackles the root cause at a bottleneck and will prevent it from happening again and becoming a reoccurring dent. During the next few IWEX meetings, the team continued to ask if the solution was still working. It was. Igor posted the completed A3 in the control room to share the fix with the rest of the operators. He asked them to bring up any concerns if this problem continued over the next 10 to 12 weeks. Sometimes dents can be fixed with small changes or just do it actions. Sometimes they require more effort. Other times, an A3 might be the best way to tackle a problem. And there may be times the issue needs to be escalated to the project cycle and tackled with a green belt, black belt, Kaizen, or other type of project. The key is to remove the source of the problem and prevent it from happening again. As Donald knows, this isn't always easy or fast, but it is worth it. With this process, Donald now knows how to identify and remove dents instead of just addressing the symptoms. Real-time data, along with IDEX and IWEX, give him and the plant team ways to discuss dents and solve them. As these dents disappear, production will continue to improve and our working environments will become safer. This has been Dent Remediation. Simply stated.